Good morning, everyone. Today we are going to be learning how soils form. I want you to watch this PowerPoint presentation before you start your workbook pages on page 37. So soils differ from one part of the world to another, even from one part of a backyard to another. They differ because of where and how they are formed. And over time, 5 major factors control how a soil forms. These factors are climate, organisms, relief or landscape, parent material, and time. That is CLORPT for short. There are 5 main factors of formation of soil. There's climate, organisms, relief, parent material, and time. Soil forms through the interactions of these 5 factors. No one factor is more important to the formation of soil in the grand scheme of things. Climate is the CL in CLORPT. It includes all aspects of climate from temperature to rainfall or snowfall to wind and amount of sunlight. As temperature increases, weathering increases. Rain or water added also increase weathering. Soils develop fastest in warm, moist climates like the tropics, and slowest in cold and arid ones, such as the climate in Antarctica. Life in the soil, or organisms, is the O in CLORPT. Roots give off carbon dioxide and organic acids that break down minerals and other organic materials. Bacteria, fungus, and worms, also called decomposers, help to break down organic material as well. Roots can physically break rocks to allow for water to enter and further weather the soil. Plant roots spread out, animal burrow, and bacteria eat. These and other soil organisms speed up the breakdown of large soil particles into smaller ones. Root, lichens, and other biological factors all combine to form soil. Roots are a powerful soil-forming force, cracking rocks as they grow, and roots produce carbon dioxide that mixes with water and forms an acid that wears away the rock. Relief is the R in CLORPT. It's also known as topography. Topography or slope position can greatly influence soil development. Think to yourself, would you rather build a dream house on the top of the hill or the bottom? Why? The primary reason has to do with drainage and water movement. Soil developed on different parts of the landscape reflect the effects of drainage. The relief, or where the surface faces, affect the soil development. Steep slopes show less development as they are likely to erode and are unstable. South-facing slopes in the northern hemisphere will show that development as they are warmer. The shape of the land and the direction and faces makes a difference in how much sunlight the soil gets and how much water it keeps. Stable or flat landscapes show more development, deeper or more horizons. Also, these areas may be an area where particles accumulate. Deeper soils form at the bottom of a hill than at the top because gravity and water move soil particles down the slope. Think back to this slide as you fill out page 37 in your workbook. Soils change on a landscape depending on where it is on the slope. This shows the names of the parts of the landscape. The next slide shows what the soil looks like at each position. Soil color changes based on landscape position. Color can tell us about how a soil behaves. A soil that drains well is brightly colored. One that is wet and soggy has an uneven, mottled pattern of grays, reds, and yellows. Parent materials is the P in CLORPT. Just as you and I have parents, so do soils. Many of the soil properties as ours are inherited from their parents. Soils that form in limestone bedrock are rich in calcium. Soils that form from materials at the bottom of lakes are high in clay. Parent materials can be broken into these 3 basic groups: transported materials, bedrock or residual material, and organic material. The group consisting of transported materials is further subdivided based upon the media that transported the sediment. Soils can also be developed in places from the underlying bedrock. These are referred to as residual material. The soil developed from the materials inherit properties from the rock and the manner in which the rock weathers, both physically and chemically. Time is the T in CLORPT. Older soils differ from younger soils because they have had longer to develop. For example, a soil in Antarctica will show very little development and appear young since it's not highly weathered. On the other hand, a tropical soil will show more development as compared to the Antarctic soil, even though it's chronologically or less aged. In the northern U.S., soils tend to be younger because glaciers covered the surface during the last ice age, which kept soils from forming. In the southern U.S., there were no glaciers. There, the soils have been exposed for a longer time, so they are more weathered. Now that you know a little more about soil formation, you can start your workbook pages, page 37 through 40. Have fun and happy learning!